right, we're going to get started with the second panel today. My name is Nick Williams. I'm the technology reporter with the Milwaukee Business Journal. I also cover startups and entrepreneurs and venture capital and sports business and housing and transportation. But I love focusing on technology, innovation in Wisconsin. Thank you, MSOE, for having me, and I'm honored to be in this room and stand alongside these amazing technologists. Just briefly want to say that we had an event early last week talking about the DNC coming and what is Milwaukee's brand going to be to the world. And Greg Nickerson of Battle Rudder said we need to put out there the innovation that's going on here. People think it's beer and brats and Laverne and Shirley, and they don't realize all the innovation that's happening in Milwaukee. And I think with this new computer science hall, with companies like Dedicated in Rockwell, and Direct Supply, what they're doing here is amazing. We just need to talk about that more. So if you want to find me after, just give me your card and we'll see if we can get an article. This panel discussion will dive into barriers faced when trying to start and complete artificial intelligence-based projects, and listening to people that I interview, in some of my articles, that can be from a talent perspective, also infrastructure, and also just simply a way of thinking. So we're going to dive right into it with our first presenter, Doug Barton, President and CEO of Ubix AI.
Oh, that's very generous to clap before you've heard the first words. Look, guys, I take the stage with a great deal of gratitude, humility. What an awesome program we've had, and of course, pride. This is my home state. I make my home in Madison, Wisconsin, and it's really great to see. My career has taken me around the world, more time in Sydney and London and Singapore, San Francisco, Toronto, than in my home state of Wisconsin, and it's so good to talk about the things I love, AI, digital transformation, right here with friends and neighbors as well. So let me jump in. I have the privilege of talking about addressing the barriers to AI project success, and with every era, it's that there's a new abundance that's created, but also creates scarcity of other important things and new barriers. And here's what we're finding in our projects. That is, there's a shortage of talent. We'll talk a little bit more about the nature of the talents we need to combine and converge and scale for our enterprises, but that's kind of the first problem that we're seeing that are a barrier to AI success. The second thing, and this was mentioned by our panelists a little earlier today, the excitement that accompanies the invention of a new neural net, right, is nothing compared to the work that needs to surround it, to put it into application, to have it have impact. There's a terrific paper that discusses the hidden technical debt of AI and data science, and that's really what we need to address, right, is that there's an end-to-end pipeline that we need to think about. And then finally, again mentioned by our panelists a little earlier today, the secret is that very little of the AI research that gets done gets into production. So there are steps, there are disciplines and practices that can improve that. So I like to think that AI success requires the development of new muscles, new competencies in the organization, and I'll talk about these each in turn, but they're the platform, they're the process, and there's the interactions or integrations. When I talk to technical people, we talk about APIs, about connecting the power of prediction to business processes. But in this case, let's just talk about impact. Impact is going to be that motivation. It's going to be that purpose that you create around using AI in your organization. It's what's going to create the resolve, right, to get the work done that will have you realize the benefits. We like to work with our clients on what we call an AI canvas that really looks at where decisions are happening in your organization across sales, marketing, operations, finance, HR, customer service, where you're making decisions under uncertainty, because that's the place to focus some of your AI energies. And then what you try to articulate is essentially where that prediction will interface with human judgment, what decisions and actions you'll take because of that, and what outcomes you need to measure to actually assess the impact of the work you're doing. And this has you reflect very deeply on the nature of the data you have, right, to both train your AI algorithms and predictions, to operationalize them, and then to improve those projects over time. The second area is AI process. And it can be daunting to essentially operationalize the continuous ingestion, the data shaping, the feature engineering, the algorithm selection, and the prediction serving and the monitoring of these processes over time. But that's essentially what it takes. You know, starting a 100-mile race across a desert without having 100 miles worth of energy or gas in the tank is not adequate. So you have to think of this holistically to address all those steps in the process. What's more, once that process is in place, that technology is in place for that, what really that unlocks is an opportunity for you to test and learn. I think one of the things that we heard a little bit about today that I'd like to bring into better relief is AI done well allows you to experiment more. Experiment differently on what actions you can take that affect the outcomes you care most about. You know, kind of think of it, the data we have of the past is just one of a number of possibilities that could have occurred. Our job is to think about how we can accumulate data about how we interact with our environment, with our customers, with our employees, with our suppliers, right, with our competitors, in a way that can result in better outcomes. So a good process is a process that puts value on testing and learning, experimentation, and of course, science and data science. And then finally, platform. This is fundamental. You know, some of the best innovations are coming from an open source community, and some of the born digital companies that are often quoted in presentations like this, an Airbnb, an Uber, a Google, a Facebook, an Amazon, they're giving rise to technology that is essential to their business, but incidental to their business model that they're making available in open source community. And that's great to get started. And especially, I want to say, you can go, farther than you think and faster than you can imagine using some great technology from the open source community. All right, so don't be daunted thinking that there's a big price tag associated with getting started. And I just called out a few here. NVIDIA, deeply respected for the deep learning work. We heard from them today. Red Hat, what they're doing, especially in the Open Data Hub. And Apache Spark, I'm mentioning here on the right-hand side. They have done wonders for access to big data, data science. Thanks, I look forward to your questions.
Hello, everybody. It's quite an act to follow. Doug and I mean, we've known each other for a couple of years now, and it's so amazing to hear his perspective. So let me introduce myself. My name is Nitin Ramachandran, and I serve as the Director of Artificial Intelligence and Market Research at Direct Supply. And I'm so excited to be here for two reasons. One, what the opening of this facility represents in terms of where we're taking Milwaukee to as a technology hub. But secondarily, I work right next door. And it's so super cool to be so close to all the innovative activity that's going to happen in this building. And I've been in the field of data science for about a decade now. As I started my career, I started as a researcher in a propulsion lab in India. It was kind of the back room in the basements. Nobody knew we existed. From there, I moved to consulting, where I was at the heart of operations of a company. And now in my role at Direct Supply, I'm fortunate to be part of a lot of strategic discussions where, as we think about where we are taking a company to in the future, data and data science is right at the heart of that strategic discussion. It's been super cool to kind of see that transition over the last decade or so, where AI has moved from the back rooms and basements of companies to the boardrooms, and that's an exciting change. As we sit here today and kind of marvel at that change, it's also important to consider some of the statistics, and Doug alluded to that, and in reports as recently as 2018 and 2019, research done by companies like Gartner and VentureBeat kind of point to the fact that 75% of AI models that are built are actually gathering dust, and 99% of AI startups in Silicon Valley are actually failing. Now, contrast this with the excitement that we all have, right? And kind of as we start looking at it, well, how can the two of those things coexist, right? And the simple fact is this, right? We're at the very infancy. AI is still at the very infancy of the potential that it can achieve. And so I'm going to try and give a little bit of a different perspective, kind of from the background of having failed many times. And the biggest piece over here is the adoption of AI in businesses, right? So, help me out with a little bit of an exercise over here, right? This is the most obvious question. How many of you guys actually use a smartphone? Raise your hands, show of hands. Yeah, that's what I expected, right? How many of you have actually read the terms and conditions of an app before you installed it? That's what I thought. All right. How many of you actually sign and review contracts at work? How many of you have signed a contract without reading it? Do you see the difference? Same set of people, same activity, two different settings, and you have completely different results. And that's one of the biggest things, right, to really understand is we can apply the same set of algorithms, the same set of deep learning methods, the same statistical approaches, the same user experience and design, but the context of where we are applying it is actually the barrier. So, I'm an engineer by trade, and, I kind of really look at everything from a logical perspective, but I'm fortunate to be married to a researcher in cognitive psychology. And over the last few years, as we've had these discussions at work, my wife has pointed me to this whole concept of human behavior and how that is central to how we operate. So at the end of the day, think about this, right? If I'm approaching you with a product that will fail at some point, and I can guarantee you that, would you buy it? Well, how is AI any different? It is probabilistic. It is not 100% accurate. It will fail, for sure. Even if it is 99% accurate, 1% of the time, it is going to fail. So how do you expect a business user to be adopting it? Think about the world that we are operating as business leaders. It's highly competitive. We're making decisions very, very fast. And there's a lot of responsibility on us to not fail. So in that context, when we have to adopt something that we are unfamiliar with, basically comes out of a black box where we don't know why it is recommending something, and there is a surety of failure, the barriers are pretty obvious, right? So this is really what got me thinking a few years back around how do we rethink the whole process of leading AI teams and building AI teams. Now, there are 3 skills that, if you Google it, what are the 3 skills that are required? You'll find a 3-way Venn diagram on any Google search. That would be statistics, programming, and business acumen. But there's one important skill set that's missing, which is understanding the human. Whenever we look at AI implementations, we're so focused on taking the human out of the loop. But think about our companies. If anybody tells you that they have perfectly clean data in their businesses, I would call them out. Because data integrity is still something we're all striving for. For most businesses, a lot of the knowledge still exists in the minds of the people who work there. And that's really what when we focus on taking the human out of the loop, we're missing out on that expertise. So the focus that we really try to shift, and one philosophy that we have adopted, and our CEO coined a great term for it, he calls it AI plus HI, artificial intelligence plus human intelligence. And it's that combination that we really bring to bear, and that's how we gain that adoption. Because when we take an AI and we bring in a human expert in the middle who can validate that, it allows the decision maker and the sponsor of AI of that AI project in the business to actually, it makes it easy for them to adopt because they have someone who's restoring trust to that project. And it's not just a data scientist walking in and saying, well, there's a 95% chance this will or won't happen, and so you should adopt it. But there's more of a trust. At the end of the day, we're all human beings, and it's really important that we kind of remember that equation. So the second part, as we think about kind of the human in the equation, is really thinking about the data scientists. So we talked about all of these skill sets that we have, and as we think through those skill sets, think about all the complexity that's involved. We all are striving to have a full stack data scientist on our team. The panelists before talked about having data scientists as a must to build AI teams. The fact is that you're not going to find experts in every field. Every field of AI is extremely complex these days. So that's the other part that I would say, focus on building the diversity of your teams. So those are two thoughts that I had, and look forward to your questions. Thanks.
Hello, my name is Jeff Krieger, and I'm the Director of Engineering at Dedicated Computing. I'm taking a different approach on this. The two barriers I want to highlight are computer hardware and computer software. So, Dedicated's tagline is powering the world's most important devices. By that, we design, develop, and manufacture high-performance computational elements that goes into OEM products. Those OEM products are used in life science environments, medical labs, operating rooms, and also training and simulation of military. All of the applications in those 3 and 4 markets are starting to embrace AI, but there's a short problem. A lot of these OEMs have to focus on their solution, and they don't necessarily have all of the knowledge, capability, time to understand how well the software is performing at a hardware level and the dizzying array of advancing hardware. So that's the first thing I want to cover is one of the barriers is hardware. In the past, we relied on Intel's clock cycle to go up to increase our performance of the application. Along came multi-core processors. Now we have GPUs, we have multiple GPUs, but there's also other additional blocks that a system developer has to consider in developing a solution. And those are FPGAs and ASICs. So I want to highlight really what I mean by those two and some of the concerns that exist in bringing a product to life. CPUs and GPUs, the NVIDIA GPUs, I'm going to term as general purpose processing elements. You can program them, they do a lot, but they also have drawbacks. They don't do some things very, very well. In terms of a GPU, they draw 250 watts of power, but they have 4,000 cores. If you're putting together a compute solution in a mobile X-ray cart or a different type of environment, are you going to have the power available? Are you going to have the ability to cool it? So when I say general purpose on the CPU and GPU, they can be applied very quickly. There's a lot of software developers. There's a lot of people that understand how to bring that to reality. On the more purpose-specific is the FPGA, the Field Programmable Gate Array, which really was developed in the early 80s. You could think of it as a software-defined CPU, and you define its processing internal elements. It's a very fast parallel data processing component. I'll give you a comparison between the two. A single FPGA may draw 30 or 40 or 50 watts to do the same amount of work that a GPU will do at 250 to 290 watts. There's a huge difference. However, in order to bring this FPGA solution to reality, you've got to overcome a number of other barriers, knowing some of that lower level hardware. So when you're bringing a solution to market in terms of hardware, there's a lot to consider. And putting 4 GPUs into a box that costs $16,000 or 1 FPGA that costs $10,000, and then understanding it. So the dizzying array of hardware, not only at the parallel computation block, but also the speed of hard drives, the speed of memory, everything is going faster. As a system developer, how do you know which components to bring in to make your application or your AI solution function, even at a higher level? I think the second bigger bucket is the software development piece. When we started, so at Dedicated, we still see customers come to us today where they'll buy the latest CPU and question why it's slower, their application is slower than the previous generation. We still see single-threaded applications. We still see the misuse of parallelizing application code at the CPU level. Now, if we start expanding OEM AI solutions, we're going to have a situation where we have CPUs, GPUs or multiple GPUs and FPGAs, all of which have their own approach to parallelizing a solution, but all of which needs a holistic understanding of the tools and the tool sets from a software development perspective on how to parallelize code, bring it together, and make decisions or solutions. So the burden of a lot of this is starting to shift onto the software developer to know how to get the most out of the hardware, understanding the various components within those blocks, how to use the compiler, all of the debugging tools that are needed to bring a solution to life. Thanks.
To the next slide, or? Thank you to all our panelists. Knowledge, Jeff, you were talking about the knowledge you have to have from a software and a hardware perspective. I'm sure all three of you have this experience when you come to a client who brings to you a problem and they're asking you to solve it. In terms of educating the client, the user, how much of that is a barrier when trying to find a solution for them? If they don't know what their problem is or what methods to even go about solving their problem, I guess, are you in the process of, you have to explain to them how the system works? I mean, time is money, so they're paying for your consultation, and they want to get this product built. So, Doug, you want to start there, just in dealing with the client or the customer, how difficult is or barrier is it for educating them on AI barriers?
Is that for me?
Yeah.
Cool, yeah. I mentioned in my opening remarks the value of having an AI canvas that actually goes through the role of AI and its contribution to an improved process, or sometimes, should we be so fortunate enough, a business model innovation. So that's a lot of the discussion that we have, and this requires that that sort of discovery of what's so for the client, what would improve a process, and it can be in some cases as simple as introducing prediction into something that wasn't intelligent before. And maybe it's call routing in a customer service call center. Just triaging calls based on what we can tell about the inbound call number and the classification or segment of the customer, the likely problem based on the equipment they have. We can get them to the right agent so they can have a first call resolution, raising customer satisfaction, improving throughput. So we have those discussions actually about laying out the power of prediction, how it fits into and interacts with human judgment, and how it fits in a process and what the outcomes we're looking at measuring. And that's a lot of what our work does in the early days. And then we're hungry to get our hands on the data. The data, not only that we can, engineer and train a model with, but the data that's available during that operational process in such a way that we can actually put it right into production and run it real time. So there's elements around the business problem we exist to solve together with the customer. We're co-creating that. the operationalizing of the AI research. Those are the biggest challenges, and a lot of times we're bringing a lot of the data science expertise that the client might be lacking in, all with an intention that first steps lead to a grander vision. I think that's what will make the biggest difference, is if we have vision, first steps, and we overcome the resistance to AI adoption by, in some ways, training everyone to be better stewards of AI possibilities.
Other panelists on that question?
Yeah, I mean, it's a day-to-day challenge that we go through, right? I mean, it's, even the earlier panelists, they kind of spoke about this, right? How do we really improve upon the statistical awareness of, our business partners, right? So there's a couple of ways we actually do this. The first thing that I believe is that when people are speaking the same language, the level of understanding improves. So what we utilize for that is an approach called design thinking, where we really sit down and go through that exercise of trying to understand what is the user going through, right? We really try to understand the context of their work, and we really try to understand what is the terminology that they're using, how do they name their challenges? And I think speaking that same language really builds that level of trust. And the business users start to also feel that we understand the context that they're working in, right? The second part of it, and I think this is the most important skill from a data scientist standpoint, is to translate the math to essentially business statements of saying, if this is the set of probabilities, or for example, if you're doing a classification problem, how do you translate a false positive rate and a false negative rate to what's actually valid for a business user, right? So I think these two layers of translation, one, where you're actually understanding the context, and second, you're actually communicating in relation to that context, right? That drastically reduces the time. It takes a bit to kind of set that process up, but once you set it up, it works really fast.
I would say that trust is probably paramount. A lot of our customers, these folks that are developing OEM-based AI solutions, have really smart engineers. They have a perception of where they want to go. For us to offer advice and to change their mind, which may be a better direction for them long-term, it is trust and demonstrating knowledge at a higher level.
We talked about trust, vision. In terms of personnel, Doug, I think you mentioned talent. How important is that when you're getting an AI project off the ground? It's having the right people in place.
Yeah, and I think the other, we heard a little bit earlier about how sort of important subject matter expertise, business fluency is to project success. And just at a technical level, there's a number of new technologies underlying AI done well and sustainably, and it's everything from data management through data wrangling and shaping. We heard that from earlier panelists. Algorithms, and there's a kind of couple classes of algorithms. Certainly machine learning gets a bit of discussion, but also just statistical inference and deep learning. Right? These are techniques that often require some specialty that you're mixing in, and you actually want to match the approach to the business problem that you've characterized. And then lastly, you can't forget that, it's been said by some luminaries that software is going to eat the world, that much of this prediction ends up in software somewhere. So we have to think of DevOps and app engineering. Or we just have a research project on our hands, right? So on a technical side, it's multifaceted, and then on top, the purpose is all motivated by the bottom line impact and the outcomes you're looking for from a business perspective.
I understand there's some NDAs involved in what you do, but if you could, for the audience, some specific situations where you had a challenge or a barrier in machine learning or deep learning or an AI project. Not to name company names, but something you or your team has experienced, so to give the audience an example.
Barriers that have been overcome?
And there's been, or failed, just.
Okay. Well, I think a part of the AI spectrum is this training, and then we also talk about inference, but there's another step in the middle, I'll call it acquisition, when we're going from an analog world into digital, we're collecting a ton of information off of an MRI ring or off of a chemical process, maybe to detect cancer as it's growing. There's a massive amount of data that needs to be brought in. That needs to be shaped and put together before inference can happen. So some of this was explaining how a compute architecture could do some of this, where the pitfalls are, understanding the market from our perspective, and having a really good understanding. So I would say a success for us is having a holistic understanding of the market, the OEM, what they're trying to build, and then the full spectrum. Because if you were just to think of AI as training and inference, you missed a big piece of data acquisition on the fly and transferring that and loading it into a method that can be inferenced upon.
They're going to another example.
Yeah, I think I can. So since you mentioned data acquisition, Jeff, I mean, let's talk about the next step after that, and I can give you an example of a project that failed. So one of the things, all of us, no matter which company we work with, we have access to data, right? The problem, though, is that data may not be perfect, and even if it's perfect, like technically or architecturally, there's a problem of bias. So let me give you an example. So for example, like we take a lot of notes about, when we have a call with a customer, and, we have a lot of notes, right? It's a great project for natural language processing. We have, so much history of those notes that are available. And we started looking through all of it. Our data scientists were very excited. A lot of approaches from an NLP standpoint, sentiment, semantic analysis, all of that, right? The problem, though, is that note is taken by, an employee. It's not actually written by, it doesn't reflect the conversation. There's bias in that data. So at some point, it's hard to think through some of those things as we start doing, because we get trigger happy and we're so excited to kind of say, here's all of this advanced technology, and like with a language like Python, you can just basically within a few lines, essentially call an entire deep learning framework, right? But what you miss out is what's the underlying issue, and if that's implemented, there are consequences to the implementation, right? And that's not something that even a business user can think. That's on the data scientist to think through that. So we've gone through some examples that are kind of very similar to that, where we had access to a lot of data, and yet we chose not to go down that path because we didn't feel like we were doing justice to the business case or the business problem that need to be addressed.
Question about secure data. I know maybe you can get an example of in the medical or healthcare industry, patient data, how that's being used in predictive analytics, and maybe in the billing process. How much of a barrier is it when the parameters around that data? How secure is it is an issue? Maybe you can dive into that a little bit, and I'll leave that to anyone to take it first.
I guess I work in healthcare, so well, it's a big problem, and there's a reason why healthcare is kind of the industry that's actually lagging behind a little bit, because there's a lot of complexity, and it's not just privacy of data as is, like my medical record, there's privacy and security around that, but there's the second concept of differential privacy, which is when you're actually running a model, how do I know that if I'm part of a study and the model is using my data, the results cannot be traced back to me? They have very, very serious implications. Like, leave healthcare. I mean, even if we were to take insurance, right? If insurance rate calculations can somehow be traced to some specific aspect of my life, well, my privacy is now compromised, right? And so there's two layers of privacy issues that are happening. The first one is, how do we actually guard the basic data? And the second part of it is, how do we actually think through, as we build these models, how do we actually think through the privacy of the data or the participants' data that we are using for the modeling? And so those are two essential barriers. One barrier is very evident, and that's what we talk about a lot in terms of security. And we're addressing this through various protocols like AI as a service. Thinking about that architecture is a great way to address that problem. But the differential privacy problem, that's just starting to surface. And it's just starting to come into conversation, and it's a problem that'll take a while to solve.
It's interesting, I'll just add to that, it's interesting that some of the smartest people on earth are thinking about how to, in some ways, de-identify data in a way so it could never be re-identified.
Exactly.
And yet not have the statistics of the underlying distribution change. So you could get the insight that chronic conditions, comorbidities happen without tracing it back to my parents, right? That would I guess I just gave away their privacy, perhaps. It was a joke illustration. But I think this is a really interesting point. I think many in the healthcare industry also believe that HIPAA in some ways has created almost a shield for healthcare, whether providers or payers to in some ways hide behind, when there are better outcomes if we could combine data thoughtfully and securely. Right, imagine what could be discovered if I can actually build a bridge between claims data and clinical data and genomic data so that we can interrupt disease, take actions sooner that save life and end suffering. Come on, that's a problem worth working on. And I'm excited about the possibilities there, and I think sometimes the security and privacy can be used as a bit of an excuse for starting such important work. Maybe MSOE and this hall will be a contribution to that future too. So,
as I think you said you were in consultancy before, so you know a lot about collaborating with other business partners. I'm sure you all do. What is the barrier of bringing two teams together from different companies, and maybe even within the same company, but you're bringing a team from a different company, or you're sitting down there and you have to collaborate your ways of approaching a project? You talked about bias a little bit too. How much of that is involved?
I think all three of us work in consulting, so any of you guys can take it too.
What was the initial part of the question?
Well, how is collaborating, if you're taking if you're a consultant or you're working with a client, you're bringing your team to their team, how much of a barrier is it having two teams sit down to get started on an AI project?
I don't think it's a barrier. Having two teams wherever they are in the world, video conference, more minds at a problem, the better the solution will become. I don't think that having two teams, they're not fighting for one side wins. There is a mutual outcome. It's more about a learning, understanding, and then bringing something to reality.
I got a comment on that. Since I'm in a small company, we're working on projects that often bring multiple organizations together, and there is a sense that we're at the knee of a huge growth curve, and that the more experiments we can conduct, right, that our interests are already aligned. So an example, working with an IoT provider of connectivity, their growth strategy is to get into solutions and analytics. We're in the business of harmonizing open source software, big data science architecture, making that turnkey, and then data science experience on top of that. And we're working with a third consulting partner who's great at connectivity and business use case and doesn't want to be in the software business. Right? They don't want to, or they just don't want to sign up for whatever Amazon will sell them, because Amazon has a long list of services, many of which can get very expensive very quickly. So we have an alignment of interests, and there's sort of a generosity that I feel in this market, because we all think that the future Jensen predicted, right, is coming true. That the more we can learn and work together, the better off we're going to be in the long term. So I think it's a unique time. I don't know that I've quite felt this way before, but then again, I was at IBM, not always known for partner friendliness, perhaps.
Yeah, and I'll add to that a little bit to kind of the points I spoke to earlier, right, which is, this is standards of how we go to market in consulting, right? The first thing we need to establish is one team. That's the basis of starting any engagement, right? So as soon as we get in, how we establish one team is essentially by saying we all have a shared fate and making sure the teams understand that, bringing them together to have a shared fate. The second part of how we look at it is essentially having the same context, right? Making sure we understand we're working within the same context. So trying to solve the same problem, trying to understand what the complexity is, what the nuances are, but having that same context. And the third part of it is clarity and transparency. Right? And when you bring these three things together, and that's really where you focus the initial part of a consulting engagement, once you get that in place, then everything else becomes easy because now you have trust in place.
One of these, this is a question from one of the audience members. What is the success rate on AA projects at your company? And is it improving over time and why?
I don't think I don't think we have any successes, and I don't think we have any failures. We have continued to mature what we hope will be something in the future. It's a lot of learning, and it just takes a long time to continue to develop the capability, especially if it's new to a large organization for internal tooling and internal knowledge.
Yeah, for us, we work in a very unique industry, which is senior living. And, a lot of the technology we have to build, the algorithms we build ground up. So our teams function very much as a research organization. I tell our project sponsors and our executives who are investing, 9 out of 10 projects are going to fail. They are. And those are the odds we need to work with, right? Because that's the reality of what we do. Now, those ideas never go to waste. Sometimes it's just not the right time. So we've had ideas that failed 3 years back, but now everything, technology is matured, approaches are matured, we can pick up the problem and be successful. So failure is not a bad thing, but we go in with knowing that we will fail, and we're okay with it.
This raises a fascinating conversation on expectations you have for success and project acceptance. I know in our work with clients is that we often describe the aspiration we have together, but we also are transparent about what we're discovering together in such a way that when we show up there, 6-10 weeks down the road, none of us is surprised or really disappointed. But sitting back, 10 weeks ago and trying to project with great detail exactly where we're going to end up is that's our first communication challenge, right? That expectation is too steep. Yep. That we're going to take this on as organizational learning and development. It can make for some moments, right? Because there is a goal behind any investment someone makes that there's going to be return, but it might not be in the horizon that they expected.
For some of if you're a more established company and you're trying to adopt these emerging technologies to make your business more efficient, is just the approach to AI a barrier? The buzzword of it. Do you see that in some of the companies you work with, that just bringing up that word, they automatically get tight and think, I've been in manufacturing for X amount of years. I know there's data in my machinery that can be pulled out, but I'm scared of going down that hole. Have you any examples you can? I see, Jeff, you're nodding your head. So
Thank you. I think there are not barriers to using AI or the like. It's more about finding the time to make the change within the organization in parallel to all the other things that are going on. I'll give you a simple example. When we develop a platform, we take it into a lab that is in a building, and we will hook up probes and we will run some tests. And this could take a couple of weeks. We have worked a year and a half to automate that so it could be done in 24 hours. The massive amount of data that we now have, and this is 2 years just to bring that to this point, now we have so much data that we probably can learn a whole new understanding of what parts are better than others. And this is another 2-year journey. But the reason it ended up being 4 years is it didn't become someone's job. It became someone's side project within the company or a group. So the challenge of really transforming through knowledge and intelligence, I don't think any company's just going to stop and say, okay, we're going to do this. There has to be some champions along the way that show some value that starts to snowball and creates an effect that is transformational.
We're going to end it there. Thank you all very. Thank you.
Disappointed with your last words?
I said something other than that.